Okay, good afternoon everyone. My name is Xavier Clerc. This talk is about running OCaml programs on a Java virtual machine. Before I start, I should mention that I'm employed at a developer position at the Ronald, inside the BASIC team, which works on the validation of systems. But the work I will present here is not is done in my free time and is not in any way supported or endorsed by the NIA. No responsibility of the NIA. Okay. So first, let's take a look at the outline. I will begin by giving a rough idea of what motivated this project and some related projects. Then I will define the objectives as well as the main features of OCaml-Java. And to conclude, I will present the various subprojects that are part of OCaml-Java, and to conclude, I will list the compatibility issues with the official release and present a sketchy roadmap. Okay, to explain what motivated the project, I put forward the following side-by-side comparison between OCaml and Java, quite classical. Concerning the language, OCaml is of course very exclusive, whereas Java is quite broad. No surprise here. Community, it seems that the OCaml community is quite small, whereas the Java one is huge. It has a very important impact on the libraries that are available, because there are only a few OCaml libraries, whereas the Java community, with its tremendous manpower, can deliver libraries for almost any task. But, as previously said, the code quality for OCaml libraries is quite high, whereas in Java, not as bad as in C, but it is pretty inconsistent.
At best.
At best. So, the idea is that mixing both languages will give access to the best of both worlds. The potential of such a combination is so appealing that some people already developed some tools. JavaCaml by Garth, which is a Java port of OCaml that need a special runtime and seems to be maintained. OCaml-Java, developed by Xavier Le Gall.
Very different from
I will explain that. OCaml-Java is bearing an interface between OCaml and Java through the native interface for Java. It is hence quite low level. It is portable, but if I am not mistaken, it implies to compile on each architecture. No? Because you go through C.
Yeah, definitely. Yes.
And last project about mixing both languages is OJaka. From I will show you in the library. It is based on OCaml-Java. It is an interface generator that uses a custom IDL-like language. It suffers from the same limitations as OCaml-Java, and it seems that it is not maintained anymore. Okay, in contrast with existing software, the objective of OCaml-Java project are 100% pure Java implementation, no native interface, the ability to run program either interpreted or compiled, to provide an easy access to Java classes. It would be, I think, a good property that the project does not use any special runtime. This means that every program compiled with OCaml-C should be up and running on OCaml-Java. And of course, it strives to be as compatible as possible with the original implementation. Another property that I think may be interesting is that several OCaml programs will be run into the same virtual machine. So here are the key points of the project. As I said, the current version 1.0 alpha is compiled from OCaml 3.10. It has been released in September, I think. The beta should be released in February with the modification from OCaml 3.10.1. It works on any Java 5 machine. It implements the whole standard library, including indexing, parsing, marshalling. And it also implements all the libraries that are distributed in the other library folder. That is big array, dynamic linking of bytecode, graphics, big number, etc. The only library missing being decay. Success still alpha. It is already able to run the OCaml top level and to build a working OCaml-C compiler. The subprojects are the following. Subproject called Barista, which is barely used for bytecode generation. Cadmium, which is the interpreter and runtime support. Cafesterol, which is the compiler itself. Nickel, which is the binding generators to easily access Java classes without relying on reflection, of course. And a very small project indeed, OCaml scripting, which is just a scripting engine based on the other projects. So Barista, it is a library for class time manipulation. It is also an assembler and disassembler for Java. It implements the whole Java 5 specification, and it depends on both CamelZimp from Xavier Le Gall and Camomile from Yori Yugi, I think. I'm not sure. It is released under the GPL, and so it can be used in any other project. On this slide, I just give a feeling of how you would write an Hello World class, both in the custom assembly language and in the OCaml data structures that represent the Java bytecode. So, here are the important parts. First, Cadmium, which is barely a Java part of OCaml1. It is also used as a runtime support for the programs that are compiled with Cafesterol. Cadmium, when used as an interpreter, implements the whole OCaml bytecode instruction set. And as I previously said, implements all primitives but the decay one. It has absolutely no dependency besides the use of Java 5 virtual machine, and is also released under LGPL. I will not comment this slide, but it shows primitive implementation of camel string get, which is a primitive used by the string module. What I could say about this slide is that it is a kind of proof that you can extend Cadmium with your own primitives. The big part of the project is cafesterol, which provides an OCaml-Java executable, which is the Java counterpart of OCaml-C and OCaml-Opt. It implements all OCaml language constructs and supports two compilation modes, in fact two linking modes. The standalone mode and the library sharing mode that I will explain later. It has some dependencies on camlzip, on Barista, and of course the original sources of the OCaml compiler. For this reason, I have decided to release it under the QPL to have the same licensing scheme as the official OCaml compiler. On this slide, I will just give a glimpse at the files that are used or produced by cafesterol, with a side-by-side comparison with classical compilers. It shares the same file format for compile interface. It introduces, of course, a new type of file, .cmj, for compile implementations. .go files are the counterpart of .o files, and so on for libraries and library binaries. The default is to link in what I call Java style. This means that you need to provide the various jar files. The standalone linking mode allows you to create a big jar file without any dependency. It is also possible to link as an applet or as a servlet. A few words about Nickel. As I said, it is used to generate OCaml bindings for Java classes. It uses the OCaml object systems and support callbacks. Callbacks are used in particular to implement event handler. In fact, a callback allows you to give the implementation of a Java interface in OCaml. No dependency and released under the GPL tree, as there is no need to link against it. Okay, this slide shows the kind of file you have to write to feed Nickel. So it is a classical XML file where you describe the various interface and classes you are interested in. And here is the kind of type that is produced by Nickel. In this example, for an action listener. You can see at the bottom of the slide the various methods that are inherited from java.lang.object. At the top of the methods, you have an action perform method. And if you take a look at the top, you can see that constructing an instance is done by feeding polymorphic variant. It is needed because you cannot have several constructors in OCaml object. And if you take a closer look, you can see a wrap variant, which is based a classical OCaml object. This is the way callbacks are implemented. In fact, you just have to provide an object that uses that provides the action perform method, and all the needed code is automatically generated. I will not give any details about this slide, but it shows how you could write a very simple graphical user interface using Nickel. OCaml scripting, as I already said, is just an implementation of the Java scripting mechanism introduced in the Java 6. Support script compilations, also support bindings, and it has dependencies on Camlium and Cafeteria. It is released under the GPL. And in this slide you have small Java fragments that shows how you can use the scripting engine to run a little OCaml code inside the Java application. I will now detail the compatibility issues with the original implementation. First, this implementation is a conduit big endian one. Unsafe features of OCaml may behave very differently, may even fail. I mean badly fail. Null pointer error, as an example, if you try to use a float as a string. Some Unix primitives that cannot be programmed in plain Java are emulated. It just means that we execute a Unix command using the shell to perform the primitive. Fonts are different for the graphics module. And this address, at this address, you can find a pretty big document, I think more than 50 pages, which is a list of all OCaml primitives with their difference with the original implementation. Now, concerning Cafeteria, the evaluation order is not the same as OCaml. This should not be a major problem, as the evaluation order is not specified in OCaml. Concerning object cache is not implemented. This should not be a major problem either, because it does not affect the semantics. It may affect, I think, some race conditions, maybe. Nothing more. Pending signals are checked at given points, which means that the application may be less active to signals. Stack overflow and memory shortage are not coped by Cafeteria generated program. It means that classical Java error will occur. Currently, the support for backslash is quite rudimentary. And I should also mention that take calls are only optimized for direct recursion. I must admit that I don't know if they are optimized in the classical compilers for mutual recursion. I'm not sure yet. In Java, it is not possible because in a Java method, you cannot jump to an offset that is outside this method. So it is not possible to have, at least to have an easy implementation of this optimization. Last point, some very big function may fail to compile just because there is a maximum size for Java methods. So when you encounter this problem that I encountered only once, you just have to turn off inlining or to split your big function in a list of smaller ones. Okay, so now rough roadmap. The first version was released in September. I hope to release a beta in February. The beta should in particular feature some JDBC bindings and also a fix for Nickel that has been reported to be broken. It seems that the Nickel version that is online is out of sync. I think I will fix it in the next few days. Then I hope to have a release candidate 1 or 2 months later. And in the long term, the objectives are as follows. 1.x versions work on compatibility features and move to Java 6 as soon as it is available on macOS. Then I think I will work on performance issues. And from this point, try to converge to use the same version number as the official OCaml distribution. And if there is a few minutes left, I may do a small demo. Okay, so here we are in the Safari browser, loading an applet. You have to trust it because Cadmium relies on Java reflection. Yes, Java. By the way, it is a 4 or 5-year-old computer. And from this point, I have a fully featured top level. And if I type the canonical factorial function, so it's barely working, and you have all the features of the top level, including, for example, the choice utility. So you can also program your own Java applets. It is still slow. When you program a Java applet, in fact, you have nothing new to learn. You have nothing new to learn because Java applets are based on the graphic module of the standard distribution. This text is read from the parameter of the applet that is entered in the HTML. And you can draw a circle by clicking and change the color by typing a key. I think I will show you the code that you have to type for this. So as I said, basically you have to use Cadmium graphics, and then you write classical OCaml functions, and you just have to register your applet in the main part of your program. Last one maybe. Just to say that I also provide some bindings for XAML, which is a Java library that allows you to write a graphical user interface using an XML description. So you can have a working graphical user interface with very few lines of code using action listeners and the like, all from the Java libraries. Okay, that's all. I will be pleased to answer any question you might have.
Is there a problem with 64-bit support?
I'm sorry.
64-bit support, is that not supported? 64-bit processors?
Yes. Well, it was an early decision, maybe not a good one, but array length in Java is I think I should check, but I think array length in Java is not 64 integer, but yes, I think this is the main reason, the only reason. If you try to write the same implementation for 64 Java, then you won't be able to create large blocks because of this problem with array length.
So can I ask, if you have, say, a string, things like string max length, it's not 16 megabytes, it's something else, is it?
No, it has the same.
Same as in OCaml.
The same restriction as OCaml.
Two questions. First, the trivial one. Does it accept the same set of command line arguments? I mean, the compiler?
Yes, it accepts the same arguments.
So it could be a drop-in replacement, almost.
Almost, yes.
Okay.
And just to a little further, it introduced new command line switches to specify that you want an applet or servlet. And if you want a servlet, you have to provide the servlet descriptor in XML. So there are new command line switches, but all existing ones are supported with the same semantics.
Second question. I'm writing static analysis stuff, and some people have asked me whether it would run inside Eclipse. So I answered, it's in OCaml, so not yet. But there is this nice project. So should I be able to make? Do you think I should be able to make a plugin for Eclipse based on OCaml source code without too many difficulties?
I hope so. The biggest program that I successfully compiled with OCaml-Java is OCaml-Java itself, and OCaml-C and OCaml-Opt. As I said, it is still an alpha version, so there can be bugs. The fact that I can make a working OCaml-C and OCaml-Opt version is a clue that there is no major bug, I think, I hope. I would be pleased to have you as a tester.
With pleasure. Not today, but thanks.
Oui.
Do you already know where the loss of performance?
I'm quite surprised that I had to wait for a question about performance. Of course, it is a major problem. I have only done a few tests that are very limited and very unconclusive. What can I say is that Café compiled programs are faster than Python or Ruby programs. This means that if a program could be written with a weak language like Python or Ruby, with no performance issue, you could use Café to write this program. This is the first thing I can say. The other thing is the other thing depends on your needs. But as marshalling is fully implemented, you can have Café compiled source communicating with OCaml-Opt compiled source. So if you have some CPU intensive tasks to perform, you can compile this part of the code with OCaml-Opt and pipe it using marshalling to a Café compiled code base for user interface, for example.
Actually, I made some benches. The loss were functional style.
Sorry, I did?
The loss was when you used functional style.
Yes.
Application.
Yes, of course. Yes. The more closure you use, the slower the program will be.
Yeah, I mean, do you have ideas about how to improve that? Or?
Yes, I have some ideas because when I started the development, I made some choices that reveal quite poor. In fact, as an example, the way values are represented in Java is very memory consuming, which puts a lot of pressure on the garbage collector, and it has a major impact on the few tests I run concerning performance. So I have quite a clear idea of what I should do to improve performance, but as I sketched in the roadmap, I want first to have a stable code base that is as much compatible as possible with the original implementation, and then I will move to performance issues. I think with better encoding, we will have huge performance gains. Because you can already have performance gain by tweaking garbage collector parameters. Performance issues of Café compiled program are tightly related to garbage collector. Because the Java garbage collector has not been designed for functional languages when you create values that you throw immediately. So by tweaking the parameters of the garbage collector, you can make things a little better.
I have a little remark about the names you used.
Okay.
Because I find the name pretty, but it's very hard to remember what it was.
Okay, so barista is a name given in Italy to bartenders which specialty is espresso. It is someone that knows how to prepare espresso. Cadmium, the name is obviously upon the zinc machine. It is a chemical element in the semicolon. Sorry. It also explains why you have a nickel subproject because of the nickel cadmium batteries. And testosterone, still chemical. It is one of the molecules of coffee.
I've got a non-technical remark. I heard of OCaml-Java, well, just project. Go on. Name it before, but I didn't look at it very carefully, and just looking at your presentation today, I think it's a very exciting project, and it serves improving and testing and so on. And in my experience, based mainly on helping in oxygen development, we started to find a lot of bugs, and we started to improve oxygen a lot when people started using it, basically. And it's not a lot of people, maybe 20 people, but it's enough. It's a use base that you need to improve it, and it goes really, really faster once you have it. And you really should put screenshots and examples and even applets on your website to attract people. Really, I felt kind of lost when I went on the website with all these sub-projects and not knowing where to begin and so on. So I would suggest you to put a simple tutorial and a few examples, your common line interpreter applets and so on, so that people can see it and realize that it's a really great project and start testing it, using it, filling the reports and so on.
Yes, I totally agree. I need more time. In fact, it is one of the two things I want to do for the beta, maybe in the future. Better website. Some simple example. The other thing is the binary distribution that is easy to install, because you have to master the compilation of the Kalman compiler to be able to use this project. So I would say that the current state of the project is that you have a very high barrier to jump over before you can use it. I am very aware of this problem, and I hope to fix it in the next few months. But I just want to say that I know this is a problem, and much of my time will be oriented towards this. Yes?
Did you run into problems with your binding generators? Because Java and OCaml-Java system are really different, and for example, inheritance is very different. So, for example, are there some Java code that doesn't naturally fit into the OCaml-Java?
There are not many problems, and I think they were under the. One of the problems is that in OCaml you only have one constructor per object, but as I showed in the example, I use a polymorphic variant. What other problem? Oh, there is a naming problem. In fact, you may have noticed on the example the java.lang.object class does feature 3 methods with the same name, wait, with different parameters. So during the translation, I just have wait apostrophe 1, wait apostrophe 2. If you want to avoid this, in the XML file you feed to Nickel, you can state which of the wait method you want, but I cannot find other problems. Well, there are the main problems I encountered. Wait.
2 related questions. What about uppercase, lowercase stuff? Java supports uppercase identifiers, lowercase identifiers, uppercase.
Oh yes, yes. They go through normalization.
Okay. And second question: what exactly is that XML file? Who writes it down?
You.
And for each Java class, we need one XML file?
No. In fact, I should have mentioned that you have one XML file per module you want to generate. And inside the module, you can have as many class or interface definition as you want.
But that's for generating code, a wrapper to call Java for OCaml or OCaml from Java?
So you write one XML file containing the information about all the classes and interfaces you want to use. You feed it
from Java? The Java classes or the
Java classes,
okay.
yes. You describe the Java classes you are interested in one XML file. Then you pass this file to Nickel, and it generates 3 files. An NL file containing style definitions and some externals. It generates a Java file containing the glue for the binding, conversions between representations of OCaml and Java values.
Mm-hmm.
And it generates a third file. Oh yes, a very dumb file, C file. Yes, it may seem quite stupid, but this C file must define all the external needed by the ML file in such a way that you can use OCaml-C to compile your program. If you don't understand what I say, forget it. It's not really
so that
important.
your OCaml-C can actually call Java?
Yeah.
Java code?
You must cheat, actually. Is it what you mean?
Not cheat. You have to provide a fake implementation in C to be able to use OCaml-C.
Okay, so it's just a stub.
Just a stub,
okay.
Where all external symbols always raise an exception.
Just to treat the linker.
Yes, exactly. Just to tweak the linker. It allows you to use OCaml-C to produce a OCaml bytecode file that can be run like admin.
Okay.
Which is quite complicated for. On the long run, we can imagine to develop a CamlP4 module to avoid the XML file.
And put what instead? The same thing, but in
The
more
same
readable
thing,
format?
But in more natural, with a more natural syntax.
But the only thing you actually need is the, unless I'm mistaken, with just the list of classes you're interested in, you could generate the XML file by parsing stuff, or am I wrong?
In fact, well, for each method, you will have to create an external symbol and a related primitive implementation.
Yeah.
So I thought it would be very consuming to generate for all the methods of a class. So in the XML file, you do not only specify which classes you are interested in, but also which methods of these classes you are interested in.
Can you
not
give an
get that
example?
from introspection on the Java side?
I'm sorry, I missed the point.
Can you not use Java's introspection to generate the lists of classes and lists of
It is on this way.
methods?
In fact, the problem is just to have to know for which class you want to which class you want to give to have access.
But so just the list of classes would...
List of classes and related method.
Okay.
To avoid to generate too much methods that are not used.
So what happens? Okay, that's if you want to. Okay, if you want object but you're not interested in toString, you just don't put toString in the list. Okay, because you're never going to call toString.
Yes.
And if you try to call toString, you have an unbound.
You have an OCaml error.
Yeah, an OCaml compiler error.
Yes.
Yeah. Okay.
Okay, can you have a way to say I want all the methods, not have to list them all?
Yes, of course. The XML file supports regular expressions for expressing the method you are interested in. The method, but not the classes you are interested in.
Yeah.
Just because in Java, if I am not mistaken, you cannot list all the class of a package.
I think I may be wrong, but I think so. I think it's possible.
If you know how to do this,
I think I saw that in the reflection packages, but I might be wrong. I may be wrong. I'm not sure.
Well, I will check.
Okay.
Yes.
The need for the XML specification is unfortunate for the user, but I think it is something like that is needed also because of the method name mangling, which would be necessary if you didn't use it, because the Java overloading of methods would generate very unnatural names for the OCaml side, right? For example, if I have the same method m, with different sets of parameters, with different types, you have to generate OCaml stubs with different names, and the user must know them without specifying them. So it would be very unusable, I think.
It is not currently possible to give the name of the method on the OCaml side.
Oh, okay. So which name is chosen?
There is a function somewhere that computes the name in such a way that it respects the OCaml guidelines. Case, capital letters are replaced by underscores, for example. And it also ensures that there is no two methods with the same names in the same object. And if there is, the first has the classical name, and the second one classical name apostrophe 1, apostrophe 2. It might be enhanced, I suppose, by using a scheme like for constructors, passing with polymorphic variants. But I thought it was a bit easy, but might be reconsidered. Right?
It looks like an impressive project, so I guess you put a huge amount of work in it. And I wonder whether it's just a hobby or if you have a specific plan to build something on top of it.
In fact, the project started because I wanted to gain some knowledge about the internal of OCaml, where values are represented at runtime, etc. So I started by developing a loader for bytecode files. Just for fun, and also because I think there is a major trend in industry today toward functional solutions. F# being a Microsoft supported project now is a clue. And as I do prefer OCaml over F# or Scala or the like, I wanted to have OCaml. Besides that, there is no precise project that I will build upon it. Using this program on multi-core architecture. It is not possible because, if I am not mistaken, inside the OCaml standard library, there are some assumptions based on the fact that there is only one thread in the runtime. So I had to make this restriction, this property, true also in this implementation. So it has the same limitation as OCaml in this approach.
You're really bug compatible with OCaml.